Can they hear it?
I don't know if they can hear you if you talk like that. But
What?
I was saying I don't know if you could talk like that if they can hear you.
Exactly.
All right, let's get our notes out. We'll do a couple long division, and then we didn't get to the new division, right?
No.
The shorter one? Okay, so we'll get to the shorter division, and then we'll also talk about factoring and solving today. So divide, factor, and solve polynomials. So we did talk about yesterday if something was missing, if a term was missing, we should add 0, didn't we?
I was looking at that in the homework and I didn't find it once.
Okay, so I think you may see some today. If not today, maybe on the review sheet tomorrow.
I thought you were going to trick me. No, I was watching for it extra carefully.
I thought it had it on number 7. And I was
That's
like,
just what I do now.
Sorry.
Because when I do your homework, I always look
And
for
it
the
usually
trick
does.
question.
I think part of it was I kind of cut back the homework from what it was last year. So I think last year was like 3 through 9. Okay, so I added the 0 in here. Oh, it's as Natalie said, it's that starting, getting going. So I know I look at the x squared. What else do I look at?
5x to the 4th.
Good. So the first term and the first term. If it helps you, write it off to the side. I divide those two things. So 5x to the 4th divided by x squared.
Is 5x squared.
5x squared. That's what goes up top. What do I do with that thing up top?
Multiply or distribute.
Yeah, which is multiplying. So I multiply, I distribute, this time to 3 things. So I'm going to get 5x to the 4th plus 10x to the 3rd. And this should be in standard form. Minus 20x squared. Got to make sure to...
Reverse the sign.
Yep, reverse. First time I've heard someone say reverse. Change the signs. That's how I usually hear it, but reverse works. So change the signs. Switch the signs.
Reverse.
Or reverse them.
I don't even know why that word came to
I don't know. It's the first time I've heard
it.
it, but it works. Minus 12x cubed plus 13x squared. And then again, I know that 0, it seems weird, but it's going to keep our terms lined up. Keep like terms, I should say, lined up. So it's kind of that sticking spot. Where do I go from there?
-12x cubed divided by x squared.
Yep, so the first term down here, first term out here. So negative 12x cubed divided by x squared. So that would be what?
Negative 12.
Yep. And again, this, the top up here, my answer, it should start going in standard form. So x squared, x, my next thing up here should just be a constant, a number. Okay, I got to take this, I got to distribute. Let's see. Negative 12 x cubed minus 24 x squared. Oh, some big numbers today. Plus 48x. I'll say it all day today. Reverse those signs. (37x squared minus 48x). Bring down minus 39. So first term now is 37x squared. What am I going to divide by? X squared. And again, if you don't want to show this off to the side, you don't have to. So it's positive 37. Done this a few times today, so I think I can do it. So 37x squared plus 74x minus 148. Change the signs. So we get negative 122x
Oh.
plus 109. Nothing to bring down. This also doesn't divide. So what do you know about this? That's our remainder. Also, another indication is this is just a constant. So that's another indication that, okay, I'm ready for my remainder. What do I always do with the remainder?
Bring it up top.
Yes.
Divide it
And
by
put it on top of
Yeah.
x squared plus 2x minus 4.
Yes.
And you add it.
That's what I was getting at. So I always add it. All those other things are also true.
What do you
So-
call the first number?
This one?
Yeah.
This is your divisor.
Okay, what's the
And your
one?
This is
Dividee.
dividend, thank you.
Oh, it's close.
Yesterday our first period called it divisee too.
Dividee.
Oh, we called it the
Yeah.
divisee.
Dividee.
So 122x plus 109 all over x squared plus 2x minus 4. Okay. Is it at least getting a little bit better?
Yes, but the long numbers aren't fun.
I agree. Let's do one more. Let's do a little shorter one. Let's do x plus 3. Oh, that was ugly. Was not much better. Let's do x to the third minus 4x squared plus x minus 7. So I'm going to go a little faster. If I'm going too fast for you, let me know. I'm going to take x cubed and x, divide them, x squared. Yep. So x squared times x, x cubed. X squared times 3, 3x squared. Change our signs. And again, some people like to change as they go. That's up to you. First term cancels. Negative 4, negative 3, that's negative 7x squared. Bring down the next term, plus x. Some people like to put 1x. At this point, you should know about yourself. You should know whether you need the 1 in there or not. We're going to take negative 7x squared, divide by x, minus 7x. We're going to distribute. Negative 7x times x, negative 7x squared. Negative 7x times 3, minus, 21x. Change our signs. Cancel. 22x. Minus 7. Is this going to be the last thing besides the remainder I put up there?
No. Wait. No. Up top?
Yeah.
Yeah, no.
Why?
You can still,
Because you can keep going.
because you can divide 22x by x and get.
So when I put that number, will that be the last number?
That will be the last.
That will be the last number. That's what I was getting at.
You
So-
still need the constant.
Yes, that's what I was getting at. So I know I need one more thing. That will be the last thing because I need a constant. Because I've got x squared x, I need that constant. So 22x divided by x. 22. Should be fun. No, it's not too bad. So 22x plus 66. Change my signs. What is that? Negative 73?
Mm-hmm.
Thank you. So plus negative 73 over x plus 3.
I always forget the plus because for some
Yeah.
reason I just with the title remainder I
get
just feel like it's
so
not
ex-
part of the problem.
You get so excited to put it up there. You're like, oh,
I
I'm
do.
done.
I get it up there and then I forget it.
Yeah, people
Sometimes
love
I
it.
forget to do it when I put it up there, but I like to rewrite it
Oh.
so I can see it better, and then I'm like, oh.
Yeah,
okay. But
Well, as long as you do that, then you're
like, when
fine.
you write fractions like 1 and 1/2, you don't write 1.
Oh,
plus
that's
1/2.
true. Yeah, that's true.
Like,
Okay,
that's a good point.
it's going to be a little flashback to geometry.
Oh.
You got a theorem.
Why?
But the good news is we're not proving anything. I just got the death glare from
We're
Jalen.
proving that I'm gonna go insane. If I
We're
don't
not
have to
proving
write down
anything.
another theorem.
We don't need to write down this part. It's just the opposite. We'll talk about it, but you don't need to write it down. So the remainder theorem. The remainder theorem says if a polynomial is divided by x minus a, then the remainder is found by substituting in x equals a.
So I know you sound like geometry.
We're not proving anything. Yes, Tristan.
So,
Since-
We got to stay on track here.
since technically theory is true, doesn't that mean that
That's why
this
you
is
prove.
all
That's
made
why
up?
you prove it. So this has been
That's what
proved.
proofs are for?
Yes.
I
It's
still didn't even know that.
enlightenment.
I've been through the class and I didn't even know that.
Well, now you know.
Proofs.
That
Right.
just shows you how much.
Right.
Proofs are so stuff.
We are recording.
Oh.
You said it pretty
Your online people are gonna have.
You
a-
said it pretty quiet. It's Shelby, maybe Logan if he tunes in.
Oh. Wait, Shelby's on there right now?
No, but she had to go to the doctor,
I thought
so
you were doing me.
no, it's a record. Everyone say hi to Shelby.
Hi, Shelby.
And Logan.
Hi, Logan. We didn't forget about you.
Is the cowboy man?
Yes.
It's good cowboy man.
He's supposed to come back tomorrow, right?
Yeah.
He was supposed to come back last Wednesday.
He's gonna be like talking to us while he's watching this.
Yeah, he should be. All right, so substituting. We've talked about substituting this chapter. What kind of substituting have we done?
Direct and synthetic.
Direct and synthetics. All right, dig out those calculators.
Come on.
Yeah.
Two.
That's what Logan always calls it, a clackalack.
All right, so we're using this example. You don't have to write it down again. But so we had this part right here. So I'll rewrite it so you can see it a little bit better. So we had x cubed minus 4x squared plus x minus 7. This is what we divided by, x plus 3. Well, okay, so it's kind of like this that I scribbled out. Well, it's just saying I'm deleting the wrong thing. It's just saying the opposite. If it's x plus, then I plug in x equals minus. If it's x minus a, then I plug in, okay. So that's just saying if I have this, I want to substitute in negative 3. So in this right here, with your calculators, plug in negative 3. So do negative 3 to the third minus 4 times negative 3 squared plus negative 3 minus 7. I ran out of room at the end. That theorem says we should get the remainder.
Here, 2. I'm on the negative 3 caret or parenthesis 2.
Plus negative 3
Plus negative.
and then minus 7.
962.
I got
I got negative 73.
It should be negative 73. We should be
Okay, guys.
getting the remainder.
My calculator.
I think a negative 1.
Here, let me write it a little bit better here.
Who got 900?
We should have parenthesis negative 3 cubed minus 4 times negative 3 squared plus negative 3 minus 7.
Just like that.
You should be getting the remainder. You should be getting negative 73.
Got it.
982. Okay.
What?
I think when I wrote
Yeah.
my cube, I put 3 minus
I did.
4 as an exponent instead of whatever it is.
Maybe my calculator.
Look, Trey, it's like a little handy.
What have you done? Oh, you times
See,
4 right here.
It's like a little
I'm going
hammer.
to add 4 right here.
Oh, okay. That's
How do you swing then?
Other way.
Oh, like this. Oh, like a hammer.
oh my gosh, Carter. Do you remember?
Oh wait, no, then it goes like this.
Oh, because it's minus 4. There we go.
Yes.
Phew.
Yeah.
Okay. Alright, everyone else have it?
Yep.
Yes.
Okay. Well, that's great. So we can plug in and we can get the remainder. What are you doing?
I was doing this.
You made a mess.
Okay, fix it. Well, but what about all that other stuff? What about
Stuff on the top.
this stuff? We need all that.
You just put what you got over the divisor,
What do you mean?
right? Because it is negative. You get negative 73, right, as your remainder.
Yes,
So then you just put it over the divisor.
right.
Over
But
the
how
top of-
But how do I get all this without having to do the long division?
Because
Good news!
it's
Good news! You don't know yet. You get to do synthetic.
oh, that's what you were saying earlier.
Yeah. So remember in synthetic when you did this and you had these numbers and then you got negative 73? And I said these numbers mean something. These numbers
Are those
give you that.
numbers.
All right, let me get rid of all these scribbles here.
Whoa. Whoa.
It all makes sense now.
That's some crazy.
Okay, so
Holy crap.
let's go back here. You still don't need this writing, but go ahead and write down allows us to divide with synthetic substitution and change to x equals a number. That will make more sense when we start looking at them.
The tweet calculator.
Then we're going to go back and we're going to do that problem with synthetic substitution.
Oh.
And so technically it's synthetic division.
What do you mean by x equals number?
So that will make more sense when I'm looking at a problem.
Okay.
Maybe let me put this here too. So like if I say divide by x minus 7, that means x equals, what do you think?
7.
Yeah. If I say divide by x plus 2,
X equals 2. Negative 2.
yeah, so you change the sign.
So it's almost like it were like equal to 0.
Exactly like that.
That's what I
That's
was
what-
gonna say
yep.
before you don't know yet.
Oh, sorry. So that's exactly
Basically equal to 0.
That's exactly why you do that. Because it's all related to that. Because in a minute, we're gonna actually factor and we're gonna solve and we're gonna see these
Oh,
things.
we're gonna solve.
Yep.
We're going.
Okay, so let's go back and let's do this problem with synthetic. So let's see if I can write that any neater. That's a little neater maybe. Okay, so that's what we're dividing. And we're dividing that by x plus 3.
No, we just did.
So that's what we just did, but now I'm gonna do it with synthetic. So we don't need our calculators right now.
I was about to just plug the whole thing in.
So we're gonna do this with the synthetic. So I'm gonna say x equals negative 3. I know we have that over here in the corner. But for my synthetic, let me draw a line. I'll even change colors.
So we don't get lost.
Yeah, hopefully. So my synthetic, I do x equals the number. I make my little box. It has to be in standard form. Well, I'm good there. No missing terms. I'm good there. So 1, negative 4, 1, negative 7. So I bring down my 1.
Negative 3.
You add them or subtract them?
I multiply on the outside.
On the inside.
And I get negative 3. On the inside, I add. So negative 7. Multiply, 21. Add, 22. Multiply, negative 66. Add, negative 73. There's that remainder that we keep coming back to. But as I was saying, these numbers, they're related to these numbers.
Oh my God.
Negative 7, 22, 22. This 1 is that one right there. We took this power of 3 polynomial. Can someone let Joe in, please? and we divided by 1. We went down 1 power. So this started with x squared. Joe, just put it in that tray right back on that shelf. Any of them's fine. Thanks. So x squared minus 7x plus 22, add my remainder, negative 73 over x plus 3. We knew it should have been the same answer. It's the same problem.
Oh my gosh.
Which one's easier?
That one.
Synthetic, I hope.
So
Okay, wait. How did you get x squared from 1?
So whatever this degree is, it's going to go down 1 degree because we're dividing by a 1 degree polynomial. So if this had been x to the 7th, this would start with x to the 6th. And I'd have enough numbers in my row to go x to the 6th, x to the 5th, and I'd have enough. Tristan?
how did you know? I think it might have been what you
Okay.
kind of just explained. How did you know to put after you like do your box and stuff? That first part. That's those numbers, but the x's. Is it
So-
just the exact same as it was?
So whatever this is, so this was, let's do a fresh problem.
Okay, yeah, because there's just
Let's-
like I'm
yeah.
looking up at the other one.
Yeah.
I'm
Let's
trying
start
to
a fresh
visualize them.
screen, fresh problem. So let's look at x to the 5th. This will be nice and long. Minus 3x to the 4th plus x squared minus x plus 2. That'll be nice and long. Divided by, I didn't mean to. It just kind of happened. We'll just do x plus 1. We'll make the number small to use.
We gotta add a 0x cubed.
Okay, so we gotta watch out for the missing terms.
Cool.
And as soon as I see the binomial, I'm gonna put in the x equals. So x equals
-1.
-1. Good. So I'm gonna put x equals -1. I'm gonna make my box. I've got a lot of 1s, so this won't take us long. If it was long division, it would take us a long time. Oops. Let's see, I've got 1, -1, -4, 4, 4,
Oh, I just opened that so hard.
-4. Was it you or was it me?
Nah, I did. I think.
Okay.
I don't have the 1 at the beginning.
Yeah, 1 for the x to the
I
5th.
forgot. I didn't even look at it.
-3, 3. Ooh, this was not my best example.
Yeah, that was
Yeah, I was confused by that.
Because of the 0 here?
Yeah.
Well, we're gonna see it more, but it didn't mean to see it this soon. Just random chance.
So no remainder.
So no remainder. So what does that mean happened?
Means it was a perfect.
It was an actual real number. It was a
An
whole
actual-
number. It was an.
It went evenly.
It went
Yeah.
evenly. That's what I was.
So
trying to
like
say.
if this were if I were taking numbers, give me an example of 2 numbers this would be.
11 minus
No,
2 and 8. So
2 and
8 is divisible by 2. 2 goes into 8 evenly. Right?
Yeah.
So that would be an example. So x plus 1 went into this big polynomial evenly. It happens sometimes.
Or.
No, it was very random that I just happened to pick 2, but hey, it happens. Okay. Are we okay with this part?
That was easy.
Yeah.
Okay, but now we gotta write our answer.
Yep.
This started x to the 5th, so my answer is gonna start with x to the 4th. I start with this coefficient. So I start with 1x to the 4th. These are my coefficients, this row. So it's minus 4x to the 3rd, I just keep going down, plus 4x squared, minus 3x, plus 2. If this had been a remainder, I'd put plus whatever over x plus 1. But since it's not a remainder, I don't really need it.
This makes so much sense.
Are you being serious or not?
No, I mean, that's
Oh, okay. I couldn't tell.
way
I couldn't tell.
easier than let's-
Okay, so why didn't we just do this? Well, this doesn't always work. This only works when we divide by these binomials. if I go back to this example, it doesn't work when I have to divide by trinomials like this, or if I have something that has x squared. It only works when I have x plus a number or x minus a number. So that's why we had to learn that long division. Good news, most of the time, I'm only going to ask you to divide by binomials. So most of the time, we're going to use this. Okay, this actually builds into what we're going to cover next.
Trinomials.
No, this example I didn't mean to make, it went evenly. So think back to those numbers that Carter just said. He said 8 and 2. So 2 is what in comparison to 8?
4 times
4.
4
What do I
versus
call it? 2 is a blank.
Quarter.
2 is a blank of 8.
LCM.
Oh, it's a GCF. It's a
Not a GCF, but it's just a factor. It's just a factor. So we have a factor theorem.
Another
Didn't
one.
I say I
theorem.
couldn't? I said we're gonna prove if I have to write one more theorem. I'm gonna look. Oh.
Now, the other classes have said Mrs. Fox really emphasized something, so I'm going to read this and I'm really going to emphasize it because they were upset I didn't emphasize. A polynomial has a factor of x minus k. If and only if.
I remember that. If and only if.
Is that what she did?
Yeah, exactly right there.
Okay.
If and only if.
The remainder
Just like that.
the remainder is 0.
Am I the only one? Trey?
Yours sounds
I don't
more
know,
like
I don't remember.
yours sounds more like her than me.
If and only if.
All right, go ahead and write that down so we can get. We have
She's gonna run over you in a second.
We have 10 more minutes. We got to get the rest of our examples in. Well, you're writing that down. I'm going to pass out the worksheets in case we're short on time.
I love worksheets.
Miss Fox. Mrs. Fox.
Yeah, I never
There are
say
numbers on the front and the back.
I never say Mrs. Fox. I always say Miss Fox.
I do that a lot, like on accident.
Is
Like
she married?
I think she is, but I do that with every teacher. Like it's just like sometimes it
Most
just
people
comes to my
on
head.
heart.
I don't think, most people, I don't think it bothers. Some people don't think about it.
It's usually Miss.
I always say Miss Honhart.
Yeah, that's what I always say. Miss Hogue, Miss Onhart, Miss Ickle. Just kind of like a habit.
But who else do I know? Wait,
So
And
you
Miss, yeah, I guess Mr. is the same.
I guess I only have Mr. Cundiff after that.
No, I don't think you should call him this.
Miss Cundiff.
Mrs. Cundiff.
Miss Cundiff.
Mr. Cundiff.
So walking into classroom tomorrow and saying,
I'm in the back.
There is a front and a back. I think you'll find a lot of it's synthetic, so it goes pretty quick. Someone is math lab today and they got it finished in math lab. Now, remember, you have yesterday's and today's, boys.
Yes.
I just caught a spelling
Yes.
error in your notes.
What?
Theorem on this one, I don't know if it's spelled right or not because the other one was different.
It's like
Renee
no, it's
theorem.
spelled right.
This one's ER.
Oh,
Oh, you spelled it wrong on that.
Because I was looking at it, I was like, why does
Yeah.
that look
you
so
put the
weird?
O in the wrong
we've gone
spot.
through the
For real.
notes. We've gone through the notes all day today, and no one's caught it.
I
Good
was
job.
It's like it says
looking at it,
there
and I
on-
was like, there is something
And you know
wrong.
what? I've used these notes for a couple years.
I
and
spelled
no
it right on my
one's caught
paper.
it. All right, let's move on though. All right, so don't write down all these directions. Let's just write factor. Whoops.
Factor of factor.
Factor given a factor. So factor given a factor.
What does that mean?
Well, I'm going to explain it to you.
This sounds weird.
Factor given a factor. So we're coming back to factoring. Surprise, surprise. This whole chapter. We want to factor, we want to solve. Those are the big ideas in the chapter. So the function they're giving us is x cubed minus 6x squared plus 5x plus 12. And then they're telling us that x minus 4 is a factor. Here's why. If they just give me this polynomial, how would you go about factoring it?
Grouping.
Okay, so don't do this, because watch what happens when I go to group it. I pull out x squared, leaves me with x minus 6.
It doesn't
G-
work.
Right, GCF there, it doesn't match.
Darn.
That's what happens probably 95% of the time. Grouping usually doesn't work. So what happens is we say, oh, we can't factor.
We need the key.
Well, so it's kind of like if I say, well, I want you to factor this huge number. Well, that's kind of intimidating. But if I say, well, break it up into those smaller numbers, that's not so bad. So they're going to give us, If you want to be like Tristan, you want to say, oh, this is like a little hint, a key.
That's what I was getting ready to say.
So they're saying this is a factor that we can divide out. So what's best to divide it out? Synthetic sounds a lot nicer to me than long division. So if they're going to give me x minus 4,
I'm gonna take it.
I'm going to say x equals 4, and I'm going to do synthetic. So x equals 4. So you're going to do a lot of synthetic. It's just what you're going to do after synthetic might vary a little bit based on the directions. So we've got 1, -6, 5, and 12. Bring down the 1, 4, -2, -8, -3, -12. Now, this one I expect to get a remainder of 0 because they told me this was a factor. So I knew I should get a remainder of 0 because I knew it went in evenly. The first one, it just happened by accident. Since this is a factor, I don't want to lose track of it. Kind of like when I have a GCF and I don't want to lose track of it. So I want to write it first. You can write it last, but we tend to forget it. So I put it down first, and then I'm going to write what's left. So it was x cubed. So it's going to start with x squared minus 2x minus 3. So hopefully now that's something we can factor.
Oh, so that just goes out.
And you can put it behind too.
That's easy.
I hope we can factor that. That should be a pretty nice one to factor. Just x and x. Same or different signs?
Different.
And 1 and -3. And again, that easy thing to forget is just the factor they gave us, the x minus 4. So front or behind, it doesn't matter. I put it in the front just so I don't forget it.
So this will be one that we don't do a lot of. This will be towards the end of the whole.
They'll be towards the end, yeah. Towards the end of one side, like when you flip it over, you'll start at the beginning again. Then at the very end, you're going to have this. It's going to say find the zeros. And that just means to solve. So find the zeros just means to solve. Well, guess what? It's going to be just like what we did. We're going to be given something. We're going to do synthetic. So you're going to do synthetic on almost every problem except the 1 or 2 practice long division I give you. It's just, was it a division and you have a remainder? Or was it, oh, I got a factor now? Or I have to factor and then I have to solve. Well, this one I'm going to factor and then I'm going to have an additional step of solving. So I've got those 4 terms. I've got x equals 3. Oh, I've got x equals. So I've got to write the binomial. What do you think the binomial is? So I'm going to write it as x minus 3, yes. Yeah. I always want you to write both of those because if you notice, we always use both of them no matter what the problem is. We just use them at different points. So no matter which one they give you, write the other one because you always want both. Which do I use for the synthetic, the equals or the binomials?
Equal.
The equal.
Oh yeah, let's go.
The equal for the or for the synthetic. So x equals 3. 1, -3, -23, 60. This is a solution, so I should get a remainder of 0, and I'm going to jot that down at the end here. 3, 1, 3, -20, -60, remainder of 0. So just like the factoring one, I'm going to put that x minus 3 so I don't lose it. Then I'm going to have x squared plus x minus 20. Now I'm solving. If I really wanted, I could do the quadratic formula, I suppose, but heck no, I'm going to factor that. X plus 5, x minus 4. And I'm solving. So I'm going to say x equals 3, x equals -5, and x equals 4. So you're going to use synthetic a lot. If you're going to divide, you're probably, remember there might be an exception or two, you're probably gonna have a remainder. If you're gonna factor or solve, the remainder is gonna equal 0. And then you guys have that worksheet. If you want, you can hang on to the worksheet since I won't be here. You can hang on to that worksheet and we can go over that worksheet and the review sheet before we take the quiz on Thursday. I think it will be Mrs. Clippinger, but I'll tell them we can collect that on Thursday. The other quick thing is the reflection will post on Google Classroom, the thing we do at the end of each quarter. That will post tomorrow. We'll wait and we'll talk about it on Thursday as well. But if you want to start looking at it, you can. So if you've got all that, you're welcome to go. Yes, Tristan.
This is what we're doing tomorrow.
That's what you're doing tomorrow. I would have it.
For tonight,
I would have it
but
ready
not-
to go for sure.
Okay.
But if you have questions, I'll be glad to go over questions on Thursday. Stop that.